data type determines the type of value, that can be stored in any reference. So data type determines the type of value that can be stored in any reference. Actually, the term data type is related to data structures. So the data type belongs to data structure. That means in memory, how to allocate memory to handle specific type of data. That is what actually the data type intention is. So data type determines what type of value that can be stored in any reference actually. So in any memory reference, actually JavaScript is implicitly typed. JavaScript is implicitly typed. Implicitly typed means that is the data type is determined according to the value assigned. JavaScript is implicitly typed. That means it doesn't have an explicit definition for data type. The data type will be determined according to the value assigned. Implicitly means internally. So that means, for example, where x equal to 10, then x is number. And where x equal to a, then x is string. X is string, like that. So the data type will be determined according to the type of value assigned. So that is in JavaScript. But important is TypeScript is strongly typed. That is, you have to define the data type. So you have to manually define the data type. And very important is it can handle only the values that are specified type. That means it can handle only the values that are specified type. JavaScript is not like that. One of the main problem with the JavaScript is, so JavaScript cannot handle the type like that. It cannot handle the type like that, right? Actually, JavaScript is nothing but, suppose you mentioned x as 10, that means it is number. Later into x, you rendered some true. Then automatically now x is Boolean. It is no longer number, it is Boolean. You initialized number, but you are storing a Boolean, assigning a Boolean, it will allow. That is the biggest problem with JavaScript. But TypeScript is strongly typed. What do you mean by strongly typed? Strongly typed means, actually strongly typed means the once you define the data type, then once you define the data type, it will not allow to store or assign any another type. That is strongly typed. Strongly typed means once you define the data type, it will not allow to store or assign any another type. That is important. JavaScript is not like that. JavaScript will handle the values. Right? So what do you mean by strict mode? I think you don't know properly strict mode meaning. Strict mode is different, strongly typed is different. So without knowing strict mode, you cannot tell that this is like strict mode, right? I think you don't know strict mode. Strict mode means the approach of coding is strict mode, not about the data types and the values. Strict mode is forcing the developers to write and approach in a specific way. It's not data type related. Data type is, I am telling here clearly, strongly typed and implicitly typed, right? Implicitly typed means it will change in any mode. It is will change. Strict mode is not related to data types. It is related to coding syntaxes. Okay, yeah. The point is strongly typed means you define the data type and it will not allow to store any another type. That is what actually the point about strongly typed. So TypeScript explicitly asks you the type, then it will fix to that particular type. Because in JavaScript, whatever the type you give, it doesn't care. For example, you are using JavaScript. In JavaScript, suppose we have a script. So we are using a strict mode, and we have a function f1, and we are using the function. And here we said var x equal to 10 and x equal to some true. So it is valid, nothing problem here. It doesn't care whether, first of all, strict mode is not related to data type and verifications. That is related to coding approach, right? That is the basic point you need to know, because somebody has pinged a message, when I turn strict mode on, it will take or not. Strict mode is not related to that actually. Okay, yeah. So strongly typed means once you determine the data type, it should not allow other types into it. That is what strongly typed is. TypeScript is strongly typed. That means, so generally we define like this. In TypeScript, so var or let, variable name, and colon, we have to define data type, and is equal to value if you want to initialize, or you can simply declare, right? We know declaration, initialization, all these points we discussed. So here important, in TypeScript, variables are declared in this way. So we need to define let, variable name, and the data type and value. That's how we need to configure. Now, what are all the data types available and how do we deal with the data types means, right? Once you define the types, that means it will not allow any another type of value. So it is restricting your variable to handle only that specific type of value. So JavaScript cannot restrict that. Explicitly, we have to use the logic and handle that. TypeScript will do that. That is ability of the data type. So many programming languages will do that. That is the reason. So actually, TypeScript follows a duck typing mechanism. So in computer programming languages, duck typing is a mechanism. Generally, software people know about this duck typing mechanism. People who are involved in programming, they know about this duck typing mechanism. Actually, duck typing means why it is called duck typing. So it is present in so many languages. Follow duck typing mechanism. So because they have an approach. Why it is called duck typing? Because duck have a unique duck have a unique duck have a unique quack, and duck have a unique walk. It have a unique quack and walk. That means when it quacks, you can know that, okay, this is duck. By hearing it itself, you can say that it is duck. And when it walks, by its walk itself, you can say that it's a duck walk, right? So that means duck have a unique representation, which is easy to understand that. So it is walking like a duck. It is quacking like a duck. So that means if it is walking like a duck, it is quacking like a duck. Press yes. So that is not ducking, right? Yeah. So yeah, even in several languages we have duck typing, right? Everything is duck typing. That means if you can correctly determine the type of an object, then it is actually called as duck typing. So it will be there almost in all languages. Majority of languages that are strongly typed, it supports duck typing actually. So the you have in Python also duck typing mechanism is there, right? So the point here is, so it exactly knows what type of data you are dealing with. That is what actually the point, right? It exactly knows what type of data you are dealing with. You can restrict the type also, right? So that is what data type. And important is generally the data types. That means TypeScript. TypeScript. TypeScript have a data type called any. TypeScript any type. Any type is the root type for all data types. Means in TypeScript, all the data types are primarily handled by any. Any is the root type for all data types in TypeScript. So all the data types of TypeScript are derived from any type. So any is the root type for all data types. It is the root type for all data types. So TypeScript any type is the root type for all data types. That means if you define let variable name as any, now it can handle a number, or it can handle a string, or it can handle a boolean like this. It can be any type. Any can handle either number, either string, or boolean. So it is the root type for all data types in TypeScript. So all the TypeScript data types are derived from any type. Any type. Now important is further the data types are classified into so many types. So further the data types are classified into two major categories actually. So what are the two major categories? That means the data types are further classified into several types. What are those? I will tell you. Actually, so the root type is the any type. Any is the root type actually. Any is the root type. So we have an any type, any, and any is the root type for all the data types. So any is the root type for all the data types. So all the data types are derived from this any type. It is derived from this any type. And this is the root for all data types. This is the root for all data types. And further, they are categorized into two groups. Actually, the data types are categorized into two groups. Technically, already I told you. So generally, so data type is actually a simple concept of data structure actually. That means what kind of data it can handle. So here the data types are categorized into two categories based on what kind of memory they use, how they handle, how they are handled inside the memory. That means what kind of memory they use, what kind of operations they handle inside the memory. Based on that, based on that, the data types are classified into two major. They are classified into two major. One is primitive types. We call them as primitive types. Primitive types. And as non-primitive types. Non-primitive types. And don't compare with your Java or .NET or any other languages, because the primitive types, the non-primitive types, so usually they depend on how that language can allocate the memory for them, how they can be accessed from the memory. So that is what actually important, right? That is what the key point actually. And don't compare with other languages that in my language this is primitive, in my language this is non-primitive, because some languages have their restrictions to handle the data. Due to that, they categorize the types into some other categories, which we will understand in later stages also detailing. Actually, the important point about primitive types is actually the primitive types. Generally, the primitive types in computer programming actually. One by one, we will detailedly discuss about them. So, TypeScript data types are categorized into two groups. So one we have primitive types, and we have non-primitive types. Primitive types. We will see one by one. First, what are primitive types? Primitive types. Actually, so the primitive types, they use a memory stack, a memory stack. They use a memory stack. So that means values are stored in a stack memory. Values are stored in a stack memory. And usually stack memory uses last in first out mechanism. That means the last value goes in, that is the first value that comes out. That is actually the stack memory behavior is. So it uses the last in first out mechanism. And very important is the primitive types are directly easily understandable to hardware services. They are directly easily understandable to hardware services. That means they are having more efficient and faster in performance. So already we know that in general other languages also. So and very important, as they use the memory stack, what happens is they have a fixed range for values. They have a fixed range for values. That means it is not like unlimited. It is not like unlimited. So that means they have a fixed range for values. It is not like unlimited. So that means you can store anything. So it's not like that. We have a fixed range for values. Fixed range for values means, so for example, so suppose what are the primitive types I will tell you. So we will discuss about that. Actually, these primitive types have a specific range. What is that range? Actually, suppose if I define uh, the numbers, for example, we have an integer, that means a number type. If I define a number type, usually what happens is the number type is designated. The number type is designated. So with by default, the range of the number type will be -32767 to 32767. That is the range. That means it stores the whole numbers from -32768 to 32767. Actually, that is the range. That means if I say that, so if it is a whole number, then it cannot be more than this or less than this, more than this, less than this. I'm just explaining the point, right? Right. Now, here we will learn so many things. We will discuss about so many things. It's a range of values, how they are defined and configured. We'll understand about that, right? So here important is, that means we have a specific range. We have a specific range. We have a specific range. That means the range is depending on what the type you have configured. That means it is to tell that it have a fixed range for values, and also can have fixed values, fixed range for values, and can also have fixed values. That is what actually the point is. That means it can be fixed range of values or fixed values, fixed range of values. So that is important. That is important. We will understand. So we will understand about these types when we start knowing about it, right? We will detailedly understand about every type and its restrictions. What are the limitations of that particular type? But important you have to know is, so generally the primitive types will have a fixed range for values. There is nothing like unlimited. There is nothing like we don't know the range. Exact range is known to that. That's what actually the primitive types. And we know we can even expect that the value will be within this. That is what important. So technically, what are the primitive types available in TypeScript? TypeScript primitive types are TypeScript primitive types. We have TypeScript primitive types are, so we have number type, we have a Boolean type, we have a string type, we have a null type, and we have an undefined type. Now don't come immediately with a question, sir, in my Java string is a reference type or some XYZ. Don't care about that. Why? Because this is not Java. So we are discussing about TypeScript primitive types. So what your language is primitive types, that's your language will tell you detailedly about. Here the point is, what are all these primitive types? That means how we can handle them and how to use them, these primitive data types, right? Actually, the number, Boolean, string, null, and undefined, these are all the types. And important, usually a number, so, and a Boolean or a string or null defined have a specific range for the values. What is that specific range for values? We will see that. We will discuss about the range of the values, how we can handle them. right? So first, one by one, we will discuss and you will get a clarity on these types, how we can use these types and work with these types, right? So technically, the TypeScript primitive types are these: number, boolean, string, null, and define. Let's see what is a number type. That means what is the purpose of number type? What is the purpose of number type? And how do we deal with this number type? Actually, TypeScript number type is used to store a numeric value. Generally, TypeScript number type is used to store a numeric value. And very important is a number can be it can be a signed integer, it can be unsigned integer, it can be a floating point, it can be a double, it can be a decimal, it can be exponent, it can be hexadecimal, it can be binary, it can be octal. So generally in TypeScript, these all considered as number type. That means if I have to deal any one of these, then the data type used is number. So number is a type used for handling signed integers, unsigned integers, floating point, double, decimals, exponent. That means if you have to deal with signed integers, means so let some n is a number, that means some x is a number type. And important, it can be a signed, means with a sign as a positive sign or negative sign. So let x as a number, so it can be like plus 10. Of course, directly plus 10 is 10 only, but it will allow the signs. It means that in a number type, you can define a number with the signs. It can be a signed integer. That is the point, actually. That is the point. That means it allows the type. So for example, see, I will define let. So here we have x is a number, and suppose I return like signed, and it is a number type, colon number is equal to, it can have a signed value. So a signed value minus n or plus 10. That means a number can be signed. Okay, good. A number can be unsigned. Unsigned means without sign, just 10. That is without any sign, positive or negative sign. So it can be an unsigned integer. So if you are dealing with a signed or unsigned number, we can use the data type as number. Okay. It can be a floating point, float. Float usually have the integer precedence, integer with 2 characters maximum, and it will have fractions also 2 characters maximum. Then it is referred as a float. That means integer value is 2 digits, and the fraction value is 2 digits, basically 1 digit or 2 digits maximum. We are talking about the maximum, right? Signed and unsigned, clearly I'm showing. Still you are asking what is difference. Who is this person? Arvind. Here I am clearly showing what is signed and unsigned. And you are still again asking what is difference between signed and unsigned. Are you not clear with the point? Signed number means a number presiding with a sign like positive, negative. That is called signed numbers. Understood, Mr. Arvind Reddy? Right? Yeah. So unsigned, that means without presiding with the signs, you are defining a number. That is floating points. These are the floating points. These are the floating points. You will learn what is the use of signed number. So without knowing all these, you can't become a programmer. Na? You are going to learn about them. Right. Now, important here is first we are understanding what is the type and what kind of value can be stored. Later, we will understand how to use and where to use. So that will not be a concern at this level first. First, you are understanding what type of value and how to write that values. Generally, if it is, so expecting the fractions with 2 digits maximum and fraction with 2 digits number, numeric, then it is floating. If it is usually double means it uses the integer, so more than 2 digits with the fraction also spanning more than 2 digits, then it is called as a double type. Usually it is called as a double type. If it is more than 2 digits, it will be called as double type. This person came with a genius question. So why you are using LET keyword? You are not following our sessions, Mr. Anil. If you are not following, then just simply, so you need to follow our sessions from the beginning, then you can understand, because already we learned LET, where. Now suddenly you came up with a question, what is LET, right? Already we discussed in the previous session, what is LET, what is var, what is const, right? Yeah. And keep your questions with you. I will come back to you so that I can talk to you detailedly and clarify your doubt. Don't ping the messages in between, right? So now the point here, double is this. So if you are dealing with more than 3 digits of integer or more than 3 digits of numeric fractions, then it is a double. And suppose we are defining decimal. Decimal is also defined as number. Usually decimal can have fractions up to 29 decimal places. 29. So maximum it will allow 29. 29. In other programming languages, many programming languages, the decimal fractions are restricted for 7 or 8. Now here the decimal can be up to 29 decimal places it can handle. So that means it can handle an accurate value. 29 decimal places it can handle up to 29. This is decimal type. Now if it is more than 7, 6, 7, 8, then it is a decimal type. So fractions, based on the fractions, how you are configuring them, right? So we can see all our numbers only, but technically we call as a float, we call as a double, or we call as a decimal when their structure is like this. Structure is like this, right? Yeah. And many programming languages have those types also, but here only one number type to handle everything. Only one number type to handle any type of number. Another option is we have an exponent type also. Exponent type usually is like this. We can say 2E3. So this is not a string. E is not a string. It is also a numeric type here. 2E3, 10E2, 4E5, like this. That is actually, it is nothing but 2 into 10 to the power of 3. 10 to the power of 3. That means it will be 2000 actually. That is its value, 2 into 10 to the power of 3. That is exponent type. So 10e2, 10 into 10 to the power of 2, right? So it is 2 into 10 to the power of 3. That is what actually exponent. So when e comes, so it is an exponent type. It is not a string or a character here. It is defined as exponent type. And it is also a number. This is a valid number. This is a valid number. So a number can be an exponent type. A number can be decimal or double type or float or signed or unsigned integer type. And very important, number can be an hexadecimal type or a binary type. Usually hexadecimal values, if you know HTML or CSS, you might have used hexadecimal values for colors. So generally how you define the colors. So by using a hexadecimal value, you can define the color range and numbers and all. Even you don't know about hexadecimal, when the situation comes, you will learn about it, because that is a general thing about when we define colors and all, we use hexadecimal values actually. So generally we define by using hexadecimal, right? How these hexadecimal values, right? Generally hexadecimal values, like it starts with, it can have different, right? Depending on the situation you are using. So for example, if you know about how do we give colors, so generally how do we give colors, then usually we have a color. Generally in HTML or CSS, how we give colors is by using a hexadecimal, we can give a color. Actually hexa will start with E to 0, 0 to F. It will be 0 to F, 0 to 9 and A to F. That is how actually it uses. And hexadecimal contains actually two. First two is for red, second two is for green, third two is for blue. So RGB and presiding with a hash actually. For colors, generally red, green and blue, like this. For example, if I write like this, hash 00 and FF and 00, then actually it is green color. If I define hash some FF 00 and 00, this is red color, like that. We have color shades to configure by using this hexadecimal. So you might have used it when you learned about HTML and all. So, but these are general references for the colors. We use a hexadecimal representation. If you are not aware of hexadecimal, later when situation comes, you will understand. So hexadecimal also comes under a numeric type, number type. Usually hexa can be like 0xf, so 00d. That is like an hexadecimal value. So later in various occasions, you will understand about that if you don't know about them. And important is LET. What that evaluates, I will show you. We can have a binary type. Binary is also a number, and usually binary type will be like 0B1010. That is a binary type. So you know the binary types. So if you don't know, no worry. When situation comes, you can understand about, because these are all general numeric representations. And we can have an octal type. So octal is also a number, and usually octal type will be like 0, O, and it will be like some 744. Different values are there. If you are aware of octal, you will understand. Not aware, don't worry. You will learn when the situation comes about them. But here, to understand that if you have to deal with an octal number or binary number or hexadecimal number, then the data type for them is defined as number only. Suppose I am trying to print here console.log. I am trying to print here. So suppose exponent. I want to print exponent value that is present in exponent. So we will print that. I'm not printing all the values. You can print all the values and see, just for reference. So suppose I want to print binary value. So binary, which we stored 0b10, we will see what it will print. We will print binary value and see what it is going to print. So similarly, if I want to know what that hexa is printing, so hexa is printing, so we will print hexa also. So, and if I want to know what this octal is printing, so I will print that also. So octal, right? So I will print that value also, that is octal, right? And if I want to see whether the decimal 29 places are allowed or not, I will use decimal. I will print the decimal also and see here. So print the decimal value, that means we use decimal. Okay, just we return a logic to print all of them. We return a logic to print all of them. So you don't need to worry about how we are printing them. Just you need to understand what you can store them, right? What you can store in that type. That is important. Let me compile this. Let me compile this and see. So I will compile this. So and run. So demo, and here say tsc demo.ts and node demo.js. I'm not printing all the values because all the values how they print we know. Just these values. You see exponent is using so this value 2000. That's what actually the exponent is. Exponent is 2e3. It is 2 into 10 to the power of 3. And binary is 10. This is the binary 10. This is the binary 10. And hexa is printing 61453. Octa is printing 484. And decimal is printing the accurate value without rounding up. So that means it can accept several decimal places, up to 29 decimal places. Otherwise, it has to round up to the nearest value and display if it is not supporting so many decimal places. So a number type, in general, a number type can be any one of these. Number type can be any one of these. So I will give this point which you can understand. Can be. So one is signed, another one is unsigned, another one is float, another is double, and another is a decimal, and octal, and it can be hexadecimal, and it can be binary, it can be exponent. It can be exponent. So this is a simple example. So for showing all the type of values that you can store. So these are all the different numeric type. Technically, you are defining a number. That means a number can be any one of these following. That means if a value is coming and it belongs to any of these types, means whether it is an octal or number, binary or hexadecimal, then we designate this. We designate with the data type as number. And you try to store any another type of value. Suppose I put in the quotes 10. It is not valid. That means you cannot assign because type this is not assignable to a type number. It will not allow to do so. Even after declaring, this is declared. And after that, unsigned is defined with some string. It is not allowing it. So once you defined as a number, that means it should be a number. It should be a number type. That's how we need to configure the numbers. So this is what actually the data type number is. So technically, so this is how we define the number. So and what various types of values that can be stored in a number reference. In the primitive types, so number type allows to store numerical values which can be any one of these following. Now similarly, Boolean, string, null, and undefined. How to handle these types, that we will see tomorrow. Mostly tomorrow will be the last session of our demo. After that, we will have a backup for everyone.